Basically speaking, angle of elevation is when you are looking at something straight across from it and raise your eyes. So like right now, if you look straight at the wall and then somebody said look up at the clock, don't you have an angle there? That's an angle of elevation because you had to raise your eyes to look at it. So if you're sitting here and you looked at the wall that is over here, and then you're still sitting there and you looked up here to the clock, don't you have a right triangle formed?
Oh, man, you do.
What?
You do.
This angle right here is the angle of elevation because it's from where I looked straight across and then looked up. Okay? Let's say that this is a 30-degree angle. And I know from where I sit to the wall is, I'm just going to make a number, 20 feet. How far up the wall is the clock?
4 foot.
Can I find that?
Yeah.
Using sines, cosines, and tangents, how does this side relate to the 30 degrees? How does this side relate to the 30? It's adjacent, right? So couldn't I go tangent of 30 degrees equals x over 20? What's tangent of 30 degrees?
0.5774.
So how far up the wall is the clock? I'd have to take 0.5774 times 20.
11.148.
You got 1.148? I got 11.548.
Pretty simple problem, isn't it? Right? Oh, another way I could have done this, if you remember 30, 60, 90 right triangles, and you have the long leg here, can I go from the long leg back to the short leg? By dividing by the square root of 3? Huh? Yep, I could have done it that way. But the biggest thing is, remember what the angle of elevation is. It is from looking straight across and then looking up. You elevate your eyes. Does that make sense? Okay. Meaning, if you went downtown, we have a flagpole downtown, right?
Maybe. We do.
Correct?
Yes.
How tall is the flagpole?
Pretty tall. 57. 4, isn't it?
I know exactly how tall it is, but
What is it?
do you want to try to run up that flagpole and measure it?
Nah, I'll do it.
You'll do it?
You get closest one to the top.
Yeah, exactly.
We'll go like how far.
Wouldn't it be easier to walk down the street a certain distance, right? And you're standing out here and you look at the bottom of the flagpole. You're right at the bottom of the flagpole, and then can't you take, you could with certain instruments, and measure an angle that looks up to the top of the flagpole?
Oh yeah, it's like that.
Called a compass and a protractor. If you looked at a protractor, you could actually do it with a protractor that's down here.
Let's do it. Experiment, field trip.
Okay? We go over here and we said that the angle was 35 degrees. And it's easy to measure the distance from here to here, isn't it? Just get a tape measure out. Okay? How far do you want that distance to be? You tell me.
27 feet. 118 feet.
27 feet?
7.
I want to find out how tall that flagpole is. If I'm 27 feet away and I have an angle of elevation of 35 degrees. So how does the 27 relate to the angle of 35? Okay? How does the x relate to the 35? So what function relates opposite and adjacent?
Tangent.
So I'd have tangent of 35 degrees equals x over 27.
18.9.
So what's the tangent of 35 degrees? 0.700. So the x would,
18.9.
I don't think that amounts to our 1.9.
no, it isn't. But it's the same idea. You
How
can
tall is
find,
it?
how tall is it?
64.
60 feet.
What did I say? I said 57. It was like 50 something.
Okay? Do you understand angle of elevation and how it's determined and how you can actually use it to find items? Okay? Angle of depression.
The other one.
The other one.
Looking down the falling.
You're exactly right. Angle of depression is you're standing up here and you look across over to here.
Okay.
Then you look down.
We're going from the clock to the outlet now.
This angle right here is the angle of depression. It's your eyes going down. Okay? Okay? Some places where you would use it, you're standing on a cliff and you're looking over at another mountain and then you're looking at the river down below.
That'd be a little bit sharp.
Just a little bit.
Okay? You're on the water tower in Clearwater and you're looking down.
My house, at the bar.
Well, we see where Blake's mine's at.
Water tower? What is that?
There's something.
The
water's on
looking
Main
for.
Street.
I know, but that was.
The water tower's like
Water tower's
the
like above everything. Yeah, I know, but still.
You can probably see every single
Why don't you
house
just say
from
the
water
park?
tower.
Say the park. Yeah. The park.
So here's the tower.
My house, you can see my house.
I don't even know where Clearwater.
We'll keep it clean.
Right there, are you kidding?
Here's Andy's house,
Yeah, we use my house.
Now what if I done?
right? This angle of depression is about 75 degrees. Water tower is about 130 feet. I think it's something like that. Huh?
Go out there with your ruler and measure it.
Well, you could find out.
Do it.
Go ahead.
The bar is closer to your house.
Okay?
I won, that's all that matters.
What he was still.
Well, I was like, wait a minute. Well, it said he's really up there.
How far away from Andy's house are you? That would actually be this distance, wouldn't it?
Yes. It's not a mile.
Okay? Because actually, if you were standing down here and had to walk to Andy's house, that's what you would be finding, wouldn't you? Okay? So, how does this side relate to 75 degrees? How does this side relate to 75 degrees? Do I have a function that relates opposite and adjacent? So the tangent of 75 degrees would equal 130 over x. Tangent of 75.
3.732.
3.732
Yeah.
equals 130 over x. So 3.732x equals 130. So x would be right around 40. What is it?
34.83.
Okay.
Not that. John? 34 feet.
Okay. Which probably means my angle of depression would have been a lot smaller to get to because it's farther away. This would be like the football field distance. But does that make sense, the angle of depression?
Yep.
Okay? An example that is in the book. Look at page 575. Here's where you get in trouble with the angle of depression. If you look at example problem number 2. Says a search and rescue team is airlifting people from a scene of a boating accident and then when they observe another person in need of help. If the angle of depression to this other person is 42 degrees, here's the helicopter. It looks straight out, looks down. This is 42 degrees, right? Okay, and the helicopter is 18 feet above the water, which means from here to here is 18 feet. Make sense so far? They want to know how far it is from here to here. Here's the other person. But my angle is up here, isn't it? Can I, if I'm going to be working with this triangle, I either need to know this angle or this angle, wouldn't you agree? To find it? And I don't care which one we have, you have two ways of finding this angle or this angle. First of all, won't these two form a right angle? Which means this would have to be 48 degrees. The other way of looking at it is this line is parallel to this line, isn't it? Which means this is a transversal. This and this are alternate interior angles, which means it gives you 42 degrees. So be careful when you're working with angle of depression that you're working with the correct angle. Okay, I want to find x. Do I want to use 48 or 42?
48. Oh, no, 42. Not 48.
All in favor of 48, raise their hand.
I don't care.
42 degrees then.
42-1.
How does 18 relate to the 42 degrees? How does x relate to the 42? Okay? So can I use tangent of 42 degrees equals what then? Equals what?
18 over x.
So what's tangent of 42 degrees on your handy dandy little calculator?
0.904.
4.
There you go, there's that.
About 20 feet? Okay. So you see how you can use the sines, cosines, and the tangents in solving everyday situations without actually going out and measuring the height of the water tower or various things, right? Okay.
Mr. Wanda, is that your bracelet right there?
My bracelet?